Hi everyone, I'm Fraser Cain. I'm the publisher of Universe Today. I've been a space and astronomy journalist for over 20 years. This is the News Bites, where we cover all of the news briefly that's happened this week in space and astronomy. Now, this is just a shortened version of the much longer email newsletter that I write every week, but we understand some people like to have the news videoed at them as opposed to reading it, so enjoy the news. The FAA has given Starship green light to fly. Well, the day has finally come. We've heard the news. The FAA has said that Starship can now fly from Boca Chica whenever it wants. And what a surprise, Starship isn't quite ready to fly. We got the news that the FAA gave them the green light. They had a bunch of additional restrictions, things like how much time they're allowed to close the roads. They're allowed like 500 hours of road closure over the course of a year. They can't do it on holidays. They have to give advance notice for longer times. They also got a bunch of environmental regulations that they had to fulfill. Things like not having excessive light so the sea turtles can't find their way back to the water and things like that. So they all sound pretty reasonable, and none are going to be that difficult for SpaceX to be able to do. But what this means is now Starship is cleared to fly 5 times per year to orbit and an additional 5 times of suborbital hops, which should be enough. This isn't a blanket permission to just start hurling starships out of Boca Chica. They still have to apply with each flight, provide all the information, and get approval from the FAA. But just in general, the concept of flying starships out of Boca Chica has been approved. And of course, SpaceX is also starting to move some of their facilities to Florida as well, to Cape Canaveral. And so we could very well see 2 launch facilities in the coming years. Now, we heard from Elon Musk that Starship should be ready to fly in July, so that's just like a month away, and then probably once every month after that. So, assuming the schedule is right, we should see Starship fly within the next month or so. A cool animation of starships launching Starlink 2.0. Elon Musk and the SpaceX team gave an all-hands meeting online with the team, and they released a video that they did for the all-hands meeting out to the public and provided a bunch of additional information. And there was a whole bunch of information about how SpaceX has been doing over the last year. They've pretty much averaged a launch a week over the last year. Their total launch cadence is still quite high. And we got a chance to see sort of how these 2 business units, Starlink and Starship, will come together. And they're planning on designing a new version of Starlink that's much bigger. It's about 7 meters long. They're calling this Starlink 2.0. And it's too big to fly in any existing rocket system. It won't fit inside the 5-meter fairing of the Falcon 9. And so it's going to need to launch from Starship. And we saw a really cool animation of how this is going to work. And essentially, these new Starlinks are going to be rack mounted inside Starship. And then it's got a deployment window up near the top. And so they're going to be raised up, kicked out the side of the Starship, raised up, kicked out of the Starship. And people have described it, it's like a Pez dispenser. At this point, SpaceX says they've built 1 of these Starlink 2.0s. And so if they're really committing to this platform, they're sort of now dependent on being able to use Starship. So it'll be interesting to see how this goes. Now, of course, one of the big issues is going to be how much light pollution will a much larger internet satellite produce. And so far, I haven't seen any estimates of how much more light pollution we're going to get from a bigger satellite above the existing Starlink platform. Gaia's 3rd data release is out. This has been a very big week. We got the 3rd data release from the European Space Agency's Gaia mission. Now, if you've watched this channel for any amount of time, you know that I am a gigantic fan of the Gaia mission. This is Europe's astrometry mission, which is cataloging an enormous number of stars. So this new data release 3, they've raised the number to 1.8 billion stars, almost 2 billion stars across the Milky Way. But in addition to that, they've also charted not just the position of these stars, but in many cases, their direction of motion, whether they're coming towards us, coming away from us, but also Gaia has a bunch of additional instruments on board that have been gathering this data, and they've been able to give a bunch of additional information. And the one that's kind of the most exciting is they have the ability to do photometry, which is to measure the change in brightness of an object, of a star. Now, there aren't a lot of spacecraft out there that can do this. Kepler was a good example. Kepler was able to measure the brightness of stars and was able to detect the existence of planets. And so in theory, Gaia can also do this. And then in addition, Gaia was able to discover a lot of very strange, they called them strange stars, stars that had weird blobs of brightness and darkness shifting around them. So it's more information for astronomers to look into. And then the other thing is that Gaia can do spectroscopy. It can help figure out the chemical signature of what stars are made of. And this allows you to start to trace back where stars came from. Are these stars part of the same stellar nebula? When did a stream of stars from some dismantled galaxy find its way into the Milky Way? And so in addition to all that, Gaia has also found many white dwarfs, neutron stars. It's found thousands of asteroids here in the solar system. It's found millions of galaxies and quasars. And, you know, it's still going strong. And so it's expected we're going to see 2 more big data releases coming out of Gaia. Release 4 and release 5. And who knows, it may last a lot longer. So a very good day for astronomy. Scientists have got a ton of new data to work with to help understand the universe. And we're going to see a lot of really interesting science results coming out over the coming months. The world's largest liquid mirror telescope has come online. So a brand new telescope has just come online in the Himalayas in India, and it's called the International Liquid Mirror Telescope. And what it is, it's really clever, is that it is a giant tub of mercury. And when you spin up this disk of mercury, the mercury flattens out and goes into this parabolic mirror shape because it's being pulled down by the gravity, but it's also turning around. And so it's following with the centripetal force outward, and it forms naturally this parabolic shape with a level of clarity as if the finest ground mirrors that could be done here on Earth. Now, the downside of this telescope is it can only point directly overhead. And so it has to view this piece of sky that essentially falls over top of it, called the zenith. But over time, as the Earth turns, the position that is directly overhead of the telescope will change, and it's just sort of constantly gathering all of this information, and it will make this information available to astronomers. It's a fascinating idea, and actually it's been tested out quite a bit here in Canada. There was a much larger instrument called the Large Zenith Telescope that was developed here in Canada. It was a 6-meter telescope. And so the 4-meter one is a version of it designed to be installed up on the top of a mountain as opposed to a test facility. And I've got an hour-long interview with the primary scientist behind the observatory. So if you want to learn a lot more about this, and I promise you, you're going to be quite surprised at some of the clever ideas that they have for this telescope, what it's capable of, and how it compares to the other kinds of observatories out there. You will be delighted when you hear how cool this idea is. Astronomers pinned down the mass of a rogue black hole. Now, we know quite a bit about black holes at this point. We know about the supermassive black holes that are at the hearts of galaxies. And we also know about black holes that are in binary systems with other stars. And you can detect the existence of the black hole because you can see how its gravity is shifting its companion star. But astronomers recently have also found a rogue black hole. And this is a black hole that is just wandering freely through the cosmos. And it's estimated there are probably about 100 million black holes, essentially dead stars, here in the Milky Way. But they're really tricky to see because they are effectively invisible. They don't emit any light. They suck in all the radiation. So how do you find them? And so what astronomers did was they used the Hubble Space Telescope and they watched a field of the sky. And they were able to watch this slight distortion that was moving through the field of view. And they were able to essentially detect that that was a black hole. And now the Hubble Space Telescope allowed astronomers to pin down the mass of this black hole. And it's somewhere between 1.6 times the mass of the sun and 4.4 times the mass of the sun. So at the small end, that actually probably makes it a neutron star. And at the large end, that probably makes it a fairly low mass black hole. So there you go. One down, 99,999,999 to go. If you enjoy the conversations that we're having here on this channel, you should join our Discord server. It's a great, active community, freely available where anyone can come and chat with other space and astronomy fans of Universe Today and the work that we do. Once a week, we have our discussion club where I and Anton, who is our producer on this show, and many other people sit down and discuss some interesting topic in space and astronomy. And this week, we're going to be talking about what is the best tourist destination here in the solar system. And in fact, Anton, who is the editor and producer on this video, he's actually got his own separate video on this exact topic, and you should definitely go and check that out in preparation for joining the discussion club. But even so, join us on our Discord server, join Discussion Club. We've got a link down in the chat below. Jupiter was hungry for planets in its youth. Jupiter and Saturn are gas giants, and so they're effectively made of the same primordial hydrogen and helium like the sun, left over from the Big Bang. But they also have heavier elements, and it's estimated that Jupiter has many times the mass of the Earth in terms of rock and metal inside its interior structure. But recently, astronomers were able to get a fairly accurate estimate of this. They did that using the Juno spacecraft. So it's an instrument on board Juno that's designed to measure the gravity field of Jupiter each time it does its flyby. And so based on the latest flyby and all the previous flybys, they were able to make a rough estimate that there's between 11 and 30 times the mass of the Earth in rock and metal inside Jupiter. And this amount makes up like a maximum of 9% of Jupiter's mass, which is a sizable amount. But one of the big questions is, like, was this just gravel that fell into Jupiter, or was it fairly large objects? Planetoids, asteroids, fairly large material. And according to the research using the Juno spacecraft, they were able to measure that the interior of Jupiter isn't evenly mixed. And so if it was like gravel, you would expect it to be quite evenly mixed inside the planet, but in fact, it's sort of blobby inside. And so there's like partially digested planetoids inside Jupiter that it consumed back at the beginning of the solar system. A bunch more updates from China. The Chinese Shenzhou 14 mission launched a couple of weeks ago, bringing the new crew to the Chinese space station. And this is important. They're going to go up to the station and be there for 6 months. But what's interesting is that now this crew and the next crew will probably overlap. So we could be moving to a time where we've got just continuous inhabitation on board the Chinese space station in the same way that there's continuous inhabitation on the International Space Station. And that would be kind of cool to think that you've got these two stations with people on board all the time up there in space. You probably remember the Chang'e 5 lander. This was the one that sent the sample return from the southern pole of the moon back to Earth. And planetary scientists working with the mission recently announced some interesting results that they had made from the lander. And that was that they had detected the presence of water on the surface of the moon, essentially beneath the surface of the lander. And it's not exactly water, it's called hydroxyl. And what it is it's one atom of hydrogen matched with one atom of oxygen, but generally it's considered an indicator that there is water there because water is just H2O. And what they found as they checked the various samples that they had seen around the lander, in some cases they were seeing 100 parts per million of water in the regolith. In one rock, strangely, they saw 300 parts per million, but on average they saw about 28 parts per million. So not a lot of water, but there is water there. And the question comes, where did this water come from? One idea, of course, is that the water was naturally formed in the rock, collected inside the moon, and has just found its way to the surface, and it's being detected by the lander. The other idea is that the solar wind coming from the sun impacts the surface of the moon, and a lot of these are hydrogen atoms, and they then bind with oxygen, and so you get water and hydroxyl just forming on the moon right there. So more research is necessary, but it's getting pretty exciting that we're finding more and more examples of there being water on the moon. Of course, that's important because when we have some future explorers that are going to go to the moon, or if you want to build propellant on the moon, you're going to want water. And it just seems more and more likely that there are large amounts of water on the moon. If you've got a lot of hard drive space, you might want to download this cool geologic map of the moon released by the Chinese Space Agency. This map has been made from the data gathered by the various orbiters and landers and rovers sent by China to the moon since 2004. And the resolution of the map is 1 to 2.5 million scale, which doesn't sound like it's very detailed, but the best map that we had access to for the longest time was one by the US Geological Survey, which was 1 to 5 million scale. And so it is twice the resolution. Anyway, you can download the entire map, but it's 150 megabytes. But once you do, you'll be able to see it's got like over 13,000 craters listed. It's got mountains, mare, a lot of really interesting features on the surface of the moon. So if you want to examine the geology of the moon, now you can. And one last piece of news coming out from China. I'm sure you've heard this. The Chinese astronomers announced that they've detected what could be a signal from an extraterrestrial civilization with the FAST telescope. You should be skeptical. I've heard from researchers who actually worked on this research saying it's almost certainly a signal of terrestrial origin. It's probably a bounced signal that came from some nearby radio tower that snuck in the side of the radio dish and caused this signal. But more research will be necessary, and it's the perfect telescope to be able to search the sky for some kind of signal from an intelligent civilization. So I'm assuming this is the last you'll hear of it, but if it does turn out to be something interesting, I'll let you know. And one last story, we've got a really cool picture from the surface of Mars taken by NASA's Perseverance rover. And this is the latest part of its journey. It came across this really cool outcropping of rock while it was in Jezero Crater. And you can see in the picture of these really cool layers, sedimentary layers in the rock. And what's exciting about this is that this is the kind of place that you might find fossils. Like this is going to be the bottom of some ancient lake bed. Got lots of interesting sedimentary features. Like if there's any place to find fossils, and like not like anyone is expecting you to find fossils, but this would be the kind of place. But what's also really cool is if you look at this picture, there's this little rock balancing on this much bigger rock. And you're wondering like, how did that get there? And we do see this kind of feature here on Earth. And what happens is you've got some sort of rock made of like sandstone or fairly soft material, and the wind erodes or the water erodes the material away until what's left is this smaller rock sitting on top of this larger rock. The other option is, those people who go down to beaches and they stack a bunch of rocks up. It could be that, but I'm going to go with natural erosion of a rock. But still, it's such a cool picture to see this rock balanced on top of this larger rock. And when I look at this picture, I just see that episode of Star Trek where Kirk battled the Gorn. So maybe that's also what it could be. We've done a couple of really interesting interviews here on the channel. I interviewed Annika Rolik about self-sustaining habitats. How will you be able to keep a space habitat going when it's far away from the Earth, when the communication delays are long, maybe when you don't even have astronauts on board to do all of the maintenance? What's the best way to do that? And if you're interested in that idea of the liquid mirror telescope, I interviewed Dr. Paul Hickson from the University of British Columbia about that. And just a few hours before this video launched, I interviewed Dr. Sunny White, who used to be with NASA Ames and is now working at a new company trying to develop advanced spaceflight concepts like warp drives. So if that topic interests you, you should definitely check out that interview. And if you want another interview, one behind the scenes, I interviewed Evan Goff, who's one of the writers for Universe Today. He's written over 1,400 articles for Universe Today. And we get into how he became a writer, what kinds of stories he's looking for, and what advice he has for people who want to become writers. That's over on our Patreon feed. It's freely available. You don't have to subscribe. Although if you did want to become a subscriber, that would be awesome. All right, those were all the top stories this week. But of course, this is just a fraction of all of the stories that we cover on Universe Today, and I write them all up in my weekly email newsletter. I write the whole thing from scratch. There's no ads, and it probably gives you 20 plus stories every week. So if you want more news, but text only, you definitely want to check out the newsletter. Go to universetoday.com/newsletter. And if you want an audio version of everything we do, you should subscribe to our podcast. Go to universetoday.com/podcast or search for Universe Today on iTunes, Spotify, or wherever you get your podcasts. If you like what we do, consider joining our Patreon. This allows us to be an independent space news journalism organization. We're not beholden to anyone else but you, our patrons. So if you want to be part of this, you can see behind the scenes. I'll remove all of the ads from Universe Today for life, and you'll know that you're directly supporting the salaries of the people who are working on this news. Go to patreon.com/Universe Today. Thanks to everyone who already supports us, and a special thanks to all the interplanetary researchers, the interstellar adventurers, and the galaxy wanderers. Your support means the universe to us. All right, those are all the stories for this week. We will see you next week.